Okay, so this is the final problem, number 6, and we're being asked when is the particle moving to the left. So it's moving to the left when the velocity is negative. Okay, so when is the velocity less than 0? So let's figure out when is the velocity equal to 0. So we'll take the velocity which we were given. No calculator is allowed. We'll set it equal to 0. And so the question is, cosine of what is going to give us 0? Well, we know from the unit circle that at pi over 2, this is pi over 2, that cosine of pi over 2 equals 0. So this piece over here, you want it to be equal to pi over 2. So you want pi over 6 times something to equal pi over 2. So if you multiply both sides by 6 over pi, you'll get t equals 3. So if, and you can test this because cosine of pi over 6 times 3 would be cosine of pi over 2. That's equal to 0. Okay, so we know that t equals 3 is definitely a solution. But think back to when you took the trig regions and you had to keep going around the circle and find other solutions and all that. The same thing can be said for 3 pi over 2. So actually another solution is t equals 9. So, and you could do that in the same way. So for example, over here, this is negative 1, 0. So cosine is negative 1. That couldn't be an answer. And over here, this is 0, negative 1. So cosine is 0 there, and that's why that's another solution. Okay, so I have t equals 3 and t equals 9, and I'm going to make my little wiggle graph. And if I choose v of 0, I'm going to get cosine of pi over 6 times 0, which is just cosine of 0, which is equal to 1, so I know that that's positive. Okay, if I try another number, for example, like v of 6, 6 is between 3 and 9. Now I could have chosen 5, but the problem is that I have to substitute into here. And if I choose 6, then the 6's cancel, and I'm just left with cosine of pi, and that's equal to negative 1. And that actually came right from there. So that's negative. And then if I do v of 12, which is bigger than 9, and I'm choosing 12 because when I do pi over 6 times 12, the 6 goes into 12 two times, and I'm going to get cosine of 2 pi, which is this point right here. And cosine of 2 pi is equal to 1, so that's positive. So we're trying to find out when is it negative, and you can see that right here in the section here between 3 and 9, that's when it's negative. So you would write, so all this work that you showed is good, and then you would write the particle is moving to the left 3 less than t less than 9, so between 3 and 9, and that's the answer for part A. Okay, I'm going to go to a new sheet for part B, which is a nice, simple, quick one. It's just going to be the integral from 0 to 6, the absolute value of v of t dt. That's the simplest one we'll ever get. Okay, part C. Alright, we have to find a of t. So v of t were given, and it was this. So a of t, the derivative of cosine is negative sine, and then you have to do the derivative of the inside, which is just pi over 6. And then, that would be the answer. I guess if you wanted to simplify a little bit, you could put that pi over 6 at the beginning. Okay, so there you go. That's the acceleration. Okay, I'm going to go to the next sheet. Okay, so here's what we're going to say. If v of t and a of t have the same sign at t equals 4, then the speed is increasing. Because remember, if velocity and acceleration have the same signs, speed is increasing, and if different signs, then speed is decreasing. This is when we would make those double wiggle graphs. Okay, so we have to see what's happening at 4. So first we're going to need the velocity at 4. So we have the velocity. So it's going to be pi over 6 times 4. And we get cosine of, this goes in divided each by 2. So cosine of 2 pi over 3. Okay, how are we going to figure that out without a calculator? Alright, well we know that 180 degrees is pi, so this is really 2 times 180 over 3. 2 times 180 is 360, and 360 over 3 is 120. So this is really asking for cosine of 120 degrees. That's what we need to find. Okay, so this is definitely a big unit circle problem. So let's make the unit circle. Okay, so 120 degrees, we know this is 90 over here and this is 180. So 120 is going to be 90 plus another 30. Okay, remember that this is going to be the cosine, this will be the sine. And this is 120 degrees. So if that's 120, that means that this has to be 60. And if you drop down that perpendicular line, that's 90. So if you have 90 and 60, then this one has to be 30. So remember, this is unit circle, so the hypotenuse is 1. And then using the rules of the 30, 60, 90 triangle, the side across from the 30 degrees is half of the hypotenuse. And the side across from the 60 degrees is the square root of 3 times the side across from the 30 degrees. Okay, so I'm now going to change this now that I know what these are. Whoops. Okay, so the x-coordinate is 1/2, but it's in a negative direction. And the y-coordinate is positive radical 3 over 2. This one's cosine, this one's sine. So we were supposed to be finding cosine of 120, so that's negative 1/2. Okay? So remember, the goal of this was to see if we have the same signs. So we know it's negative. Actually, I just realized something, that you didn't even have to figure out all those sides, because if you know on the unit circle you're 120 degrees, which is right here, you know it's got to be a negative x and a positive y. So cosine would have to be negative, and sine would have to be positive. Okay, but hopefully you learned a little something there, but you could have saved some time. Alright, now we have to check the acceleration at 4. Okay, so for the acceleration, it was negative pi over 6, sine of pi over 6, and now we'll multiply that by 4. Two goes into 4 twice, and 2 goes into 6 3 times. Okay, and this is again 2 pi over 3, so this is the same thing. This is the 120 degrees. So we're going to have a negative pi over 6 times sine of 2 pi over 3. So before I erase this, I guess you can go backwards if you wanted to watch the video again. We had it, I guess I'll just quickly draw this right here. This piece over here was, we said this will be negative for x, positive for y, cosine, and sine. So we need this, sine of 2 pi over 3, so the sine is going to be positive. So a negative times a positive is negative. Okay, so here's what we have found. Let's just kind of sum this all up. A little different color. Okay, we found that v of 4 is negative and a of 4 is negative. So now we can say since v of 4 is negative and a of 4 is negative, the speed is increasing, because if the signs are the same, it's increasing, at t equals 4. Okay, and finally, I'm going to go to part D. This is the longest question in history. Where is the particle at t equals 4? So I sent another video before about this, and hopefully this will make a little more sense. So to know the location, remember you need the original. We don't have the original, we just have the velocity. So if I do the integral of the velocity, that will get me back to the original, going from 0 to 4. That will tell me how far I've traveled from 0 to 4. But I have to know, where did I start? Where was I at 0? And that was a given, I believe. Yep, that x of 0 is negative 2. So to this, we have to add a negative 2. Okay, so first we're going to have to do this integral, and you have to do it by hand. So the antiderivative of cosine is going to be sine. Okay, so let's check and see if this works. So the derivative of sine of something is cosine of something times the derivative of the something, which is pi over 6. So we have a pi over 6 too much, so we have to divide it by pi over 6 as it goes from 0 to 4. Okay, so remember, if you are dividing by pi over 6, that's the same thing as multiplying by 6 over pi. Okay, and that's what we need to solve. So first we're going to put 4 in there. And then we're going to put 0 in there. Okay, and thankfully sine of 0 is just 0. And then don't forget, we still have this minus 2 we have to take out. Okay, so I'm just going to make a little bit more room and erase up here. Okay, so we have 6 pi. Okay, sine of, well, 4 over 6 can be simplified to 2 over 3. So sine of 2 pi over 3, we've already done that, and that's radical 3 over 2. That was from the unit circle. So it's this piece, minus, I'll just put it in here in case you forgot, it was 0, and then you still have to subtract this 2. Okay, so simplifying, 2 goes into 6 3 times, so we have 3 radical 3 over pi minus 2. And that was the answer, and we're finally done.